Newton's laws of motion. Let us see what is force. Force is an external effort or cause which can be in the form of a push or pull, which either changes or tends to change the state of rest or uniform motion of the body along a straight line. There are two types of forces, contact and non-contact force. Contact forces are the forces which come into play due to actual contact between the bodies. For example, frictional force, tensile force in string, normal reaction, air resistance. What is non-contact force? The force which come into play without any physical contact between the bodies. For example, gravitational force, electric magnetic forces are all the examples. What is inertia? The inherent property of all the objects that they do not change their state of rest or uniform motion along a straight line unless acted upon by an external force. That is inertia. What is inertia of rest? It is the inability of body not to change it by itself its position of rest. For example, when a bus or train starts suddenly, a passenger standing inside it leans backwards. When a hanging carpet is beaten with a stick, dust particles are cleared. Another example, when a card carrying a coin and placed on a bottle is flipped away quickly with a finger, the coin falls in the bottle. When we shake a branch of a mango tree, the mango falls down. A bullet fired against a window glass makes a clear hole in the glass without cracking it. These are all the examples of inertia of rest. What are the examples of inertia of motion? Let us see what is inertia of motion. It is the inability of body not to change by itself its state of motion along a straight line. For example, when a bus is moving or a train, it suddenly stops. A passenger standing in it leans forward. A passenger getting down from a speeding bus falls in the direction of motion of bus. And athletes run with some distance before taking a long jump. These are all the examples of inertia of motion. What is inertia of direction? It is the inability of body by virtue of which it tries to resist a change in its direction of motion. For example, mud flying tangentially to the surface of the tire of a car. That is an example of inertia of direction. Okay. Now let us see about Newton's first law of motion. It states an object at a rest tends to stay at rest, and an object in motion tends to stay in motion with the same speed in the same direction unless it is compelled by some external and unbalanced force to change that state. This is Newton's first law of motion. Now this can be taken by this way. When forces are balanced, if objects are at rest, that means velocity is 0, its acceleration will be 0, the object will continue to stay at rest. If they are in motion, then velocity is not equal to 0, but there is no acceleration. If there is constant velocity, then we can say there is no acceleration. In such case, the objects in motion stay in the motion with same speed in same direction. So this is Newton's first law of motion. Let us see about linear momentum. The product of mass and velocity of a body is called linear momentum. Now let us take, suppose a car of mass m1 and truck of mass m2, where m2 is greater than m1, are moving with same velocity. If P1 and P2 are the momentum of car and truck, then we can write P1 by P2 equals to m1 v1 by m2 v2, and here velocities are same. So P1 by P2 is equals to m1 by m2. We know m2 is greater than m1. If m2 is greater than m1, then P2 must be greater than P1. From this what we can say? A heavier body has a larger linear momentum than a lighter body when they are moving with same velocity. Let us see next case. Let us take same car of mass m1 and truck of mass m2 are moving with v1 and v2 velocities, and they are having same momentum. So if their linear momentum is same, but they are moving with v1 and v2, then we can write m1 v1 equals to m2 v2 because their linear momentums are same. So v1 by v2 is equals to m2 by m1. v1 by v2 equals to m2 by m1. And we know m2 is greater than m1. If m2 is greater than m1, then we can write v1 is greater than v2. From this what we can say? A heavier body has smaller velocity. If the body is heavier, then it has smaller velocity than a lighter body having same linear momentum. Let us see some important points about momentum. We know P equals to m into V. From this, if mass is constant, then we can write P is directly proportional to V. That is, it is directly proportional, meaning the graph between P and V will be a straight line. That is, m equals to constant. So here P equals to mv. This we can compare it to the general equation y equals to mx. So where m is the slope. So here m will be mass and that is equals to slope. Let us see in the next case. If momentum is constant, then we can write mv equals to constant. That is P equals to mv, that equals to constant. Then v is inversely proportional to m. That means the graph between velocity and mass is v is inversely proportional. So it will be a rectangular hyperbola. It is like this. Let us see this case. If velocity is constant, we know P equals to mv. So v will be equals to P by m. If we know v is constant, so P by m equals to constant. Then P is directly proportional to m. That is, momentum is directly proportional to mass. So the graph between momentum and mass will be a straight line. Again, yes, velocity here is constant. Now let us see about Newton's second law of motion. The rate of change of momentum of a body is directly proportional to the applied force, and this change takes place in the direction of applied force. This is the law. The rate of change of momentum of a body is directly proportional to the force applied, and this change takes place in the direction of applied force. So F is directly proportional to change in momentum. Rate of change of momentum, that is dp by dt. This I can write F is equals to d by dt of, we know momentum equals to m into v. So F is directly proportional to, let us take m out. If m is constant, then velocity may be changing. So we are writing m outside, assuming it to be a constant, then dv by dt. F is equals to k into m into dv by dt, where k is proportionality constant. So F is equals to kma. Why? Because dv by dt we have studied it as acceleration. Rate of change of velocity is acceleration. Now, if force is equals to 1 Newton and mass equals to 1 kg and acceleration is equals to 1 meter per second square, then we can say k equals to 1, then F is equals to mass into acceleration. Now let us see about the units of force. SI unit of force is Newton. We know it is mass into acceleration. Mass, its unit is kg, and acceleration, its unit is meter per second square. So we can write 1 Newton equals to 1 kg meter per second square. What is the CGS unit? It is dyne. 1 dyne will be equals to 1 gram centimeter per second square. Let us see the relation between Newton and dyne. 1 kilogram equals to 10 cube gram, that is 1000 grams. 1 meter equals to 100 centimeter. We know 1 Newton equals to 1 kilogram, 1 meter by second square. 1 kilogram is 1000 grams, 1 meter is 100 centimeters by second square. So it is 10 power 5 centimeter gram per second square, and gram centimeter per second square is dyne. We know that. So 10 power 5 dyne. Let us see something about gravitational unit. It is 1 kilogram weight, that is nothing but 1 kilogram force. This can be written 1 kilogram into 9.8 meter per second square. Okay, so this is equals to 9.8 Newton. Now 1 gram weight. 1 gram weight is nothing but 1 gram force. 1 gram into 9.8 meter per second square. So it is in meter per second square, but I want in CGS unit. So I am converting it into centimeter per second square. So 9.8 into 1 meter is 100 centimeter by second square. So that is equals to 9.8 into 100, 980 grams centimeter per second square or 980 dyne.